Right, next up, this is the multiplication law. It is simple. Anytime that you hear and you multiply it together. Okay? So, you go to the bookies, which you shouldn't do, but the probability that Man United wins is 0.6. The probability that Liverpool wins is 0.4 at the moment. What's the probability that Man United and Liverpool win? Yeah, you multiply them together. The probability of Man United and Liverpool winning. 0.6 by 0.4, 0.24. I'm pretty sure that equals to. Okay, that's that probability done and dusted. That's how they come up with accumulators. Yes, never bet on an accumulator. Even if you think that that's where they rob all your money. It's stupid. Do not do it. Do not gamble. Right, multiplication law. Now, I'll run through some of the examples and I'm going to just say straight away why their example's bad. Okay? Straight away, example 1, it says 2 dice are drawn. Whenever you hear 2 dice are drawn, you're doing two-way table. Okay? Which, have we done? Not sure we've done, or we will do in the future anyway. I can't remember, have we done it, because I'm teaching loads of different people at the same time. I've taught probably 6 years just before this. So I get confused all the time. But if I say, what's the probability in my first one I get a 6, and probably on my second one I get a 5? It's 1/6 by 1/6. That's 1 over 36. Next one, 2 spinners are spun. Yeah, really simple. You can see in that. Well, both show blue. Well, the first one is 2 out of 6 areas, and then the next one is 2 out of 6. Yeah, that's going to come out as a 9th. 1/3 by 1/3. Easy. Yep. Now, you got to remember, every single one of these is mutually exclusive. You can't have an overlap. Yeah, because defense are independent. Sorry, defense are independent to each other. Yeah. So if you look at spinner A, it's spinner B. A doesn't impact B. So they are mutually exclusive. Or sorry, not mutually. They are independent. Now that's why we're multiplying them together here. Yep, mutually exclusive is when we add. So forget that. What happens in A does not affect B. Yep, very simple. If I was going to give you a few more examples, what's the probability of Paul Basquel making the NBA due to his height, and the probability of Izu making the NBA? Okay, and the probability of Odie making the NBA. Paul, he's a tall man. We got to say 0.7. Izu, he's a beast, but he's not as tall as Paul. Okay, and Odie, 0.99. That guy is guaranteed to be in the NBA. So what's the probability all to make it? 0.7 by 0.6 by 0.99. What's the probability Paul and Odie? 0.7 by 0.99. Izu and Odie, 0.99 by 0.6. Simple, really, really easy. Now, example 4 is what we've got to get our heads around. It's about that whole birthday one. So, all these events are independent of the other. So, 3 pupils, A, B, and C, have their birthdays in the same week. A, B, and C. Okay, what's the probability all their birthdays are on Monday? A 7th, a 7th, a 7th. Easy. Birthdays on Mondays. What's the probability that A, I'm just going to give you different ones now. A and B have their birthday on Monday, but C's got different. Well, A and B, it's 1 over 7, 1 over 7 that they're both Monday. C, then is told, it has to be a different day. So they got 6 out of 7 to go from. Yeah. What's the probability that they all have their birthdays on a different day? Yeah. So this is where we have to use a bit of common sense. On a different day. Right. So let's say we just say this first person has their birthday on a given day. Yep. So let's say it's a Monday. Yep. Then this person has to have their birthday on a different day. Agreed? So they got 6 out of 7. But this person has to have their birthday on a different day to this person and this person, so they got 5 out of 7. Now, anybody with a bit of common sense is going to say, that's just what it is for Monday. But what if this person had it on Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday? There's 7 options there, isn't there? So you would multiply that by 7, which will make that 7 over 7. And that's your answer. Now, fall in 3 different days. Yeah, they explain it down there. Somewhat okay. Not as good as me, if I gotta say it. Fall on the same day. If they all fall on the same day, it's 1 over 7 by 1 over 7 by 1 over 7. That's the chances of Monday. But then there's Tuesday, Wednesday, Thursday, Friday, Saturday. So this is on the same day, so you'd multiply that by 7. That's going to be 1 over 49. I don't think you're going to have any problems with this. Homework's going to be question 1 to 15 or 45 minutes. If it says hypothetically here, Monday's the birthday of one or both. Okay, well this is the probability that this is the probability that Monday is of both. Yeah. Yep, we'd agree. This is the probability of A and B having it the same. So let's go. So the question is, after birthdays, 2 have it on the same day. Okay? So this is the probability that 2 have it on the same day. Yeah, A and B have it on the same day. And let's say that's Monday. So we multiply that by 7 because there's 7 days in the week. So it could be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, blah, 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 blah. But we could also have A and C have the exact same. So A and C have the exact same. And multiply that by 7. Or B and C. And that would tell you the days in which they all have it, add all that up on the both days. Agreed? Complicated. I was about to say it's easy, but it's kind of complicated. But different days then, we worked out here. And we'd add that on, that they have it on different days. The question was, so that's for both days, and then if they said it on, if they have their birthday in both days, or, yeah, let's just leave it to both. I'll leave this out to stop confusion. Now, if I wanted to do this in a slightly different way, yeah, hopefully you don't get confused by this. We understand it's 1 over 7 by 1 over 7 by 6 over 7. We multiply that by 7. And I could have just done 3 choose 2 for here. 3 choose 2 would have given me, well, 3 choose 2 is 3. So I'm multiplying this by 3, which is, these are all going to have the same probability. So it's this multiplied by 3, it would give you this. 3 choose 2 would have been, you got 3 people, you have to put them 2 together. So A and B, A and C, B and C. So don't worry if you can't get that at the moment. You will by 6th year. Enjoy your homework. Question 1 to 15. Great work.